All right, I'm going to try and make sense of the lab. This is a went through just a few moments ago. Yesterday, I asked you to really just do steps 6 and 8 so that this first data table could get filled in, where you're going to multiply the mass, 0.163 kilograms, times the number 10. That would give us 0.163 newtons. That's how we change kilograms to newtons. Then we're going to take these 3 times. I did the 3 trials of the ball down the ramp. I add all 3 of them up and divide by 3, and when I do that, I get an average time of roughly 1.04 seconds. Now I have information in this data table that I take to page 2 so that I can come up with an average speed. I'll take the length of the ramp, which is 0.61 meters long, and I'll divide that by my average time of 1.04 seconds. And because I have very little time to do this, I'm just going to narrate through as much as I can. I want you to show as much as you can. 1.04 seconds. And then when I get an answer here, I take that down to number 2 and I just multiply it by 2. It's this final speed that we're after to calculate the kinetic energy. So I want you to see that everything kind of flows from the top data table that we did yesterday down through our calculations today. So in the live lesson today, I showed you that we're going to take our mass, which is 0.0163 kilograms. We're going to multiply that by our final speed from step 2 right up here. And when we report our final speed, it's roughly 1.17 meters per second. This is a value that we have to square. So order of operations wise, how do I make that superscript? I can't figure that one out at the moment. We're going to put this whole thing over the number 2, though. We have to divide this in the end. So order of operations wise, now it's set up. That setup was a little confusing. I apologize. We're going to square this number first. Then we're going to multiply it by this. And then we're going to divide by 2. Do your best to show your 3a, your 3b, and your 3c. Calculation of gravitational potential energy is just the weight of the ball. That's this value right here. By the height of the ramp, that's this number right here. So that's a 1-step math operation. Now we're done with all of our calculations. So it's only when your calculations are complete that you come down to your conclusion questions and you compare GPE to KE. And again, in number 2, I'm asking you how the 2 compare. You should notice that the GPE is slightly larger than the kinetic energy. What is the ball experiencing as it goes down the ramp? There's a little hint for you. There's some interaction between the ball and the surface of the ramp. And then number 3 is just a practical application. If you're going to coast down a hill, a big hill versus a small hill, which one are you going to go faster on? I think that part's pretty easy to understand, but tell me why. Tell me why you would go faster at the bottom of a big hill compared to a small hill. See if this helps. Send me any messages, direct messages with questions on Edmodo.